Good afternoon or good morning, everyone. Thank you very much for joining. This is the Steinmeyer webinar on the concept of zero maintenance ball screws, and we are going to turn it over to George.
Thank you. As you can see from the, I hope you can all see the slide. First of all, appreciate everyone taking the time to join us today. This is a subject that is near and dear to my heart because I see, I read the trade press, still in print version. That'll give you some idea of you know, where I'm coming from. But I see, you know, lots of promotional pieces and ads for something called zero maintenance. And in this case, we're talking about ball screws because that's something that's especially relevant to Steinmeyer, but it also applies to any linear motion component. And the title of this presentation is that the basic concept of zero maintenance ball screws is in fact a lie, and we hope to clearly indicate why we believe that to be true and our alternative solution for that. Sorry, we're having a little bit of technical details on, there we go, okay. So here is the brief agenda. There will be a brief, I'll give a brief introduction and then indicate why we believe zero maintenance ball screws do not in fact exist. The alternative from our perspective is something that we label reduced or minimal maintenance, and the vehicle by which that is achieved is something called a combination wiper, which has been in use for quite a number of years from Steinmeyer. There's a brief conclusion, and then certainly we'll have open it up for some questions and hopefully some answers. Okay, so, you know, obviously, you are, as well as the rest of the world, is familiar with any you know, company making machinery out there, certainly, and using machinery wants to keep productivity as high as possible with zero downtime, if possible. But the question is that possible? And you know, the term zero maintenance sounds obviously very appealing, and the question is, can it be true? And like other things that sound too good to be true, they usually aren't. So from our perspective, we believe that that is not true. So another way to present that is asking a question: could a ball screw or a linear motion component really be infinitely lubricated throughout its life? And clearly the answer is no, and we'll present that, the reasons why. And so, you know, from our perspective, we firmly believe that you can never truly eliminate maintenance, but you can certainly reduce it considerably. So what do we mean by what is the concept of zero maintenance? So it really means one of essentially two elements, two things, namely that the ball screw runs dry, and for anyone who's used ball screws, you know that that's really not a very good idea. Or the ball nut includes enough lubrication to protect it essentially infinitely, forever. Again, from our perspective, neither situation is realistic, possible. Essentially, the real reason and the fundamental reason is that linear devices move. So you have one element moving against another element, whether it's a guideway or, in this case, a ball screw. And because the moving element cannot be completely sealed, the net effect is that lubricants escape by the nature of the device. So it's not possible to completely retain lubricant like you would in for example, a rotary bearing. So that's why we believe that lubricant, you can't fill a ball nut to such an extent that it's going to be continuously provide lubrication throughout its an infinite lifetime. So is it feasible to run completely dry? Our experience is no. Ball screws do require some minimal, albeit very small amount of lubricant to enable the balls to recirculate inside the nut. If you're running completely dry, that is with some sort of dry lubricant coating, dicronite, tungsten disulfide, things like that, that eventually does lead to balls jamming if there is no additional lubricant provided. It could be even 1 or 2 drops of oil, but you need something to efficiently allow the balls to recirculate smoothly, and that's especially true if you're running under very slow rotation conditions or reversing. So basically, our position is, you want to beware of any promotional ads or articles offering the following idea that for any linear motion component, you can basically install it and forget it. From our perspective, that just does not exist. It does, however, exist for rotary bearings, and that we firmly believe that's a valid situation. And there's one simple reason for that. That is, rotary bearings don't move axially. They go round and round in one place, and so you can provide very efficient seals and retain lubricants, and that's certainly not the case in ball screws or guideways. Now, there are some suppliers out there that offer oil-impregnated wipers, and so oil-impregnated wipers, and the concept is the wiper presses against the shaft as it moves, heats up, and basically some oil seeps out, leaving a thin film of oil behind, which is a great idea in principle. The issue is that the concept of it is based on the wiper actually being able to reabsorb some lubricant as it passes over the other element. So, in theory, it sounds like a great idea, and in theory it is. But there are two, basic flaws. One is that heating things up is really not a good idea, and we find it to be a disadvantage. Obviously, you want to minimize the amount of heat that you're putting into an element. And then the second thing is that the whole concept is based on reabsorbing lubricant, in other words, so that it lasts a long time. But how is that possible? And all you have to do is look at a ball screw or a guideway that's been moving back and forth, and what do you see at the ends of the element? You see lubricant, and that means that oil or grease has escaped, and it's not being not possible to reabsorb it. So the net result is that with something like that, oil will run out, and the wiper will need to be replaced. And in the meantime, the ball screw runs dry and fails prematurely. Obviously, a bad thing. So from our perspective, reduced maintenance is a much more realistic concept, it means obviously that you still have some downtime, albeit minimal. But with an element that we're going to introduce here, the amount of maintenance required is greatly reduced. Instead of multiple times a year, it may be once a year or every 18 months. And again, the key element here is that there is some sort of lubricant reservoir. So essentially what we're saying is, instead of believing in something that is clearly questionable, if not an outright fiction, you stick with something called greatly reduced or minimal maintenance. And so from our perspective, such a device is what we call a combination wiper. Okay, and before we get into such reservoir wipers, there's a little bit of digression and on lubrication in general. So if you look at the whole idea of lubricating ball screws in this case, what you want to do is establish an elastohydrodynamic film, and especially for certain duty cycles, especially oscillation and slow speeds. And you want to select an oil or a grease with a proper grade and viscosity. And oil, our first suggestion is always to use an oil because of its optimum characteristics in terms of removing heat. And grease certainly has an edge at the slower speeds. But by offering essentially a clear wear protection under mixed conditions. Steinmeyer actually participated in a technical study with a Swiss institute several years ago. The results are on our website. They are still valid, although some of the products actually have been taken off the market. In any event, what we did was, or actually what the Technical Institute did with some of the components that we provided, they simulated both slow and fast-moving ball screws. Clearly, for the worst case is the slow-moving ball screws. Fast-moving, you can use almost anything as a lubricant. But basically, the test involved building the lubrication film and also measured wear rates. Some lubricants, some very popular lubricants, actually yielded low friction, but very high wear at the same time. So it would behoove you to when you have a chance, take a look at the website. You'll see it listed as a lubricant test under our technology section, and basically greases performed very well. And one of the greases that is on there is, let's see, it's the 1, 2, 3, 4. It's the fifth one from the right, which is a Kluber NBU ADP, which is the one that we tend to favor for our products when nothing else is specified by the customer. It's a pretty good common moderate wear rate. It's very effective grease. So anyway, getting back to our solution or projected solution, we have developed something called a combination wiper, and what you'll see on the shaft here is actually several wipers. The combination wiper is only the one where you see the cursor, which is the one that's leftmost on the shaft, and the combination wiper is basically a dual stage device which is added to a ball nut. It has an external friction wiper, which is the blue plastic that you see. Actually, the second wiper on the shaft, looking from the right side, is also shown there. That's the blue friction wiper. That's actually inside the combination wiper, and that faces out towards the outside world. So its function is to prevent contamination from getting inside the nut. And anything that gets past that wiper is captured by a secondary wiper, which is made of felt, which is shown here. And felt, as you may know, is an excellent oil absorber, and basically that's the lube reservoir that is utilized in the combination wiper and enables it to be used in a reduced maintenance situation. So what are the advantages here? You can see two different versions of the combination wiper. One with a blue friction wiper that's on the right, and that piece is injection molded, so that's done for high volume production. And then this other wiper, which is made from white Delrin, is actually machined, and that's for some of the lower volume products for which injection molding is not economical. So, you know, combination wiper is certainly a proven technology. It's been around for probably 10 years anyway, maybe more. So again, superior dual stage sealing. You've got the blue friction wiper on the outside plus the felt, which traps anything that gets past the blue wiper, such as fine dust and particles. Greatly reduces maintenance, reduces lubricant consumption as much as 3/4 to almost 90% less, and it is refillable, and that's a key element here, because if you happen to utilize one of the oil impregnated plastic wiper products that are on the market, you do not have a choice of lubricant. With the combination wiper, you do. So basically, wrapping this thing up from a conclusion perspective, from our viewpoint, zero maintenance for any linear motion component, whether it's like ball screw products, basically from our perspective, zero maintenance simply does not exist. So from our point of view, it's really just a marketing term, and frankly, an insidious one. Basically, regular lubrication leads to a long lifetime, reduces risk of major problems. And a combination wiper is a path towards lubricating with minimal attention, certainly not zero maintenance, but certainly greatly reduced maintenance. That's it.
So George, we had a couple questions come in during the presentation and a few beforehand, and if our audience will stick with us and ask any questions using the chat feature, which is enabled in the webinar UI, so you can ask one. Feel free. The first question, George, is are wipers like the combination wiper are from one supplier compatible with another supplier's ball screws?
Well, unfortunately, no, because every ball screw manufacturer uses their own thread groove profile. Therefore, the Steinmeyer combination wiper is only applicable to Steinmeyer ball screws.
George, second question was, are these wipers compatible with any lubricant?
Theoretically, the answer to that is yes, but the best approach there is to contact Steinmeyer, or basically your ball screw supplier of choice, if you will, and ask that question, because there are certainly lubricants that are more appropriate for ball screws. As a general rule, when we talk to customers, we recommend that they use lubricants that are rated for gearboxes, and that is a simple way of stating that you need a product that is capable of surviving very high pressures, which you experience in a ball screw.
George, we've got a two-parter here at the end, and this is from the same individual. He says, I have an especially dirty application. How often would I have to change these combo wipers?
That's a very good question, and in a classic application engineering sense, we would reply, it certainly depends greatly on the application, specifically what you're machining, and how often you're running the machine. Our general recommendation is that in the first year you check fairly often. By fairly often, I would say maybe once every 6 months. And if you're still seeing lubricant on the shaft, and it's going to be very thin, but if you wipe your finger on it, you'll be able to determine whether there's any lubricant film on the shaft, then you're probably okay. If it feels dry, then you need to refill the reservoir.
And the second part, George, was, how would these particulates or the contamination impact zero maintenance versus the combination wipers?
Again, the purpose of the combination wiper is in the case of really bad machining, such as cast iron or quartz or ceramics. The felt does a really good job of trapping those small particles, especially when you're doing something like grinding. In that case, you do have to inspect the wiper inside. Since the combination wiper, since half of the combination wiper is inside the ball nut, you have to physically pull it back and inspect the felt strip to see how loaded it is with particulates. If it is especially loaded, then obviously you would replace it. How often you do that, again, is going to depend largely on what you're doing, how many hours the machine is running, and clearly the type of lubricant that you're using. And so, yeah, I would certainly say recommend that you check certainly at 6 months, and again at 6 months. At that point, you may be able to back off. So.
Well, that's our questions, George. I'd like to thank everyone for attending. If you have follow-up questions, you can see George's email on screen, and you can certainly ask him oh, we do have a question.
Yeah, we do have a question. The question says, question asks, are combination wipers expensive, and can you retrofit? Combination wipers, as you saw from the graphic, there is some dimensions. There are some dimensions to them, obviously, and they are external to the ball nut, so they do add some length to the ball nut, which obviously it takes away from the nominal travel of the ball screw. The cost is relatively insignificant compared to the price of the ball screw. If I were to hazard a guess, it's probably a few percent at this point. It's not that. Again, obviously, it depends on the cost of the ball screw itself, but just to give you some idea, I mean, the combination wipers are typically for a ball nut are under $100. And the second part of it is, can they be retrofitted? The answer is yes, but you would need to have access to both ends of the ball nut. So in some cases, you might have to remove the ball nut from the shaft. That's not that difficult to do. We are certainly able to provide the mechanisms or give you the dimensions for what you need to use in order to safely remove the ball nut from the shaft.
George, we have another one here. Is the Kluber microlube compatible with Vogel systems?
NBU ADP compatible with Vogel systems. Yeah, I'd have to check that. NBU ADP is not really a pumpable grease, so I don't know. I'm not sure. Let's see. The gentleman who posed this question is certainly familiar with microlube, but I think might be referring to another microlube product. I don't believe that NBU ADP is a microlube, but in any event, to my knowledge, the NBU ADP is probably too thick to be compatible with Vogel, but I can double check that.
George, that's the end of the questions, and I think you probably want to follow up with that one. If anybody else has questions, you can see George's email at the bottom of the screen, and you can certainly do so, and we will make this presentation available to you all. We're going to be having another webinar in the beginning of March, and stay tuned for more information on that. So thank you very much for your attendance, and we look forward to seeing you in the future. Thank you now.